Saxon Algebra 1, Lesson 83. Oh, you guys, this is a magical day. We're going to learn how to do a problem called coin problems. These are classic algebra problems, and they're going to be kind of the basis for a lot of different problems that we'll do. So we'll be doing these in variations for quite a long time. And they involve a system of equations. And you guys know a lot about systems of equations. You know that we can solve them with substitution. And you know that we can solve them with elimination. And you also know that we can solve them by graphing, but we're not going to waste any time on that with these. Okay? So we'll be using substitution and elimination. We're going to set up the variables. I'll make a list over here too. We have a special way that we set up the variables in these. What we're going to be looking for, and you'll see when I read you one of these, we'll be looking for how many quarters, how many nickels, how many dimes. I can't think of any problems where we do pennies. But we're looking for the number of the coins for our answer. Not the value of the coins, but the number of the coins. And so this is the way we set up our variables. That would be the number of nickels. This would be the number of dimes. This would be the number of quarters. It allows us, when we use these variables, it allows us to match the variable to the words in the sentence. That's the whole reason we don't just do X, Y, Z. We could. And when I learned algebra, that's what we did. But that's what John does that's really clever, is he makes his variables match the words so that when you are reading the sentences, it's a lot easier to translate your sentence into an equation. So, what else do I want to tell you? We need one equation for each variable that needs to be solved. Or found, or however you want to think of that. Most of ours will have two variables, and so we will have two equations in our system. That's what we're used to, right? Later on, I think next year, I think it's the red book, we'll have some problems that have three. But for now, we'll just be working with two. That's what we're used to, okay? Now, the other trick, and this is true for all word problems, when we read the problem, I'll just write it all and then I'll talk about it. I'll give you a chance to catch up on the last one. As we read the problem, which is in words, we look for, I wrote statements of equality, but that's such a John way of saying it. We look for things that are equal. That is the normal way to talk about this. John's going to tell us this equals that. This is equal to this. We look for those statements, and that's how we build the equations. We take those statements of things that are equal, and we build them into equations. This is the part that everybody chokes on, and that's fine. You'll get the hang of it, and it helps to know the strategy of what we're doing ahead of time. Let's dive in. I love these problems. P.S. 83.1. Jack and Benny have 28 coins that are nickels and dimes. Okay, so they're not talking about how much they're worth. They're talking about taking a bag full of coins, or a piggy bank, if you will, dumping it out on the floor, not caring what kind of coin they are, but just going, oh, look, these are all nickels and dimes, and there are 28 in all. Here's the way we write that in an equation. The number of nickels plus the number of dimes equals 28. Notice that we're just talking about the number of coins. We're not talking about how much money they're worth. This is called a quantity statement. And I'll tell you why this is important in a minute. Okay? It's just talking about the quantity, not how much the coins are worth. The next part of the sentence says, if the value of the coins is $1.95, how many coins of each type do they have? Okay. Now we have to take into account that nickels are worth 5 cents and dimes are worth 10 cents. Okay? So what we're going to do is I'm going to write this in cents. So if we multiply 5 times the number of nickels that we have, plus 10, because 10 cents is what each dime is worth, in the end, we will have, what did John tell us? $1.95. Okay? And we call this a value statement because we're taking into account how much each coin is worth. There's only one problem. I wrote 5 cents and 10 cents, but then I wrote this as $1. This has a decimal in it. So I have to change either these into decimals or take the decimal out of this one. And you can guess which way I'm going to go. I don't want to put decimals in all of this. That's drama. So I'm going to say, okay, $1.95 is how many cents? Well, it's 195 cents. And that is a much better number to work with, right? I just I multiply it by 100 because there's 100 cents in every dollar. So 195 cents is the same as 195. Now everything is written in cents, and I am ready to solve my equation. Now, before I go on, though, I just want to say a few words about this quantity and value idea. In future lessons, we're going to take this same framework, the same idea, and we're going to use it to solve problems that are not about coins, that are maybe, oh, there's one that's about going to a fishmonger's and buying cod and mussels. Okay, that's fine. Quantity and value, how many pieces of fish and how much they are all worth. There's another one that talks about dress shops. And in this dress shop, which is such an old-fashioned idea. I mean, I guess it could be an online shop, but the idea that there used to be just like dress shops is such a weird thing now. They only have 2 kinds of dresses, you guys, a more expensive and a less expensive. So we talk about the number of dresses and how much each one is cost. There's another one that talks about tickets on a plane. Again, this is very old-fashioned. There are 2 seats, first class and coach. And now there's like every seat's a different price, right? The number of seats and how much they're worth. So we're going to take this quantity and value idea and play with it in some other lessons. What I'm going to do to remind you is I'm going to do this on the outside of my equations for a while to remind you this is what a quantity statement looks like and this is what a value statement looks like. Okay, are you ready? We're now going to solve this little puppy dog. And we can use substitution or elimination. And in these problems, here's the fun part, you guys. John lets you choose. He does not tell you to use substitution or elimination. He just says, tell me how many of each coin we have. So you get to choose. So what I'm going to do is I'm just going to mix it up. I'm going to use substitution on the first one. There are a total of 3 in this lesson. So I'll do substitution, elimination, and then I'll flip a coin for the last one. So let's use substitution. I see we've got a nice thing here we can rearrange. So I'm going to subtract the number of dimes, and that will reshape this into number of nickels equals 28 minus the number of dimes, right? I just subtracted it. Now I'll substitute that in right here. So 5 times 28 minus the number of dimes plus 10 times the number of dimes equals 195. You already know how to do substitution, and I believe we've already done a lesson where you started doing it with these wacky subscripted variables, which again, they don't change anything. They just make the words match the variables better. And that's good. Okay, so now we're ready to distribute. Let's see. That would be 140 minus 5 times the number of dimes plus Tn times the number of dimes equals 195. All right, this is looking good. We can combine like terms and subtract 140 on the same step. So this will be 5 times the number of dimes equals, and what'll that be, 55? Yes, divide by 5. And we get that the number of dimes equals 11. Okay, beautiful. And then we pick one of these equations. I mean, we could pick this one too, but why would we want to, right? Oh no, this one doesn't have the number of nickels in it, so we do need one of these. We choose one of these and we plug this in to find the number of nickels. I can do this one in my head. They have to add up to 28, so this must be 17, and then I can check it just like that to prove it. So here is my answer. Yay. Make sense? So our friends Jack and Benny must have had 11 dimes and 17 nickels, and if we wanted to multiply that and add that, I mean, we can do that easily, right? This would be 110 cents, and 17 times 5 would be 85 cents. And we add it up, and look, there's $1.95, 195 cents. Okay, so it works. Yippee for us, right? It's good. Okay, that was substitution. By the way, in the book, John shows this problem worked both with substitution and elimination because he's committed to showing you all your options. I am too, but I'm just going to show you in a different way. 83.2. Ming has $4.45. I'm just going to jot that number down. We'll need that later. $4.45 in quarters and dimes. She has 8 more quarters than dimes. Okay, now let's be careful about how we write this. The number of quarters is greater than the number of dimes, right? This is our quantity statement. I'll read it again. She has, and I'm covering up the number, she has more quarters than dimes. Okay, that's right. The magic number to balance it is 8. She has 8 more quarters than dimes. That means we need to add the 8 to the smaller side, right? Now they're equal. Oof, those greater than or less than statements are tricky. Write the inequality first and then use the number to balance it. Okay, she has 8 more quarters than dimes, and they add up to 445. Okay, so now we can do the value statement. 25 times the number of quarters plus 10 times the number of dimes, 25 cents for a quarter, 10 cents for a dime, equals $4.45, but we have to write it as cents and not a dollar. 4.45. Yay. This time we're going to eliminate, right? So, I mean, it's all set up to substitute, but I promised I would eliminate. How would we do this? We can't compare these as they're written because this one is not in the same format. So what I have to do is rearrange this. Number of quarters, and I have to swim the number of dimes back over. So it's minus number of dimes equals 8, right? I just swam that way. Now, I'll write it underneath here. Now I can multiply. Let's see, if I multiply by 10, this will cancel. These are both plus, so I'd rather not. I'd rather multiply this bottom one by 10, and then the dimes will cancel out. So now let's multiply everything. 10 times the number of quarters minus 10 times the number, dimes equals 80, right? Okay, now I'm going to gently squiggle that, and I'm going to add these two. 35 times the number of quarters, yay, that cancels, equals, oh, this is a big number, 525. Yikes. I see long division in my future, right? That's good. 525 divided by 35. Well, 35 into 5, nova. 35 into 52 goes once. 17's left over. Bring down the 5. Okay, how many times would I guess 35 goes into 175? Okay, I'm just going to pretend it's 3. 3 into 17. 3 times 5 is 15, so let's guess a 5 and see what happens. 5 times 5 is 25. 5 times 3 is 15, plus 2 more is 17. Yay, it worked out. So this reduces, and we get the number of quarters equals 15. Yay, that's right. Okay. And now we can go back to our original equation. See, now I like it like this because I know that 15 equals the number of dimes plus 8. So if I subtract 8 from both sides, I get 7 equals the number of dimes. I'm sorry, nickels. No, I'm sorry. My mouth is talking about the old problem. First we found the number of quarters. Now we're finding the number of dimes. 15 is the number of quarters. I plugged that in. This is right. I subtracted 8. 7 equals the number of dimes. Yes, these are the right answers. And I like to have the numbers together if at all possible. But if I didn't write that over and I just had one box up here and one box down here, that's okay. But ideally, I like to see both answers together. All right, one more of these lovely, luscious coin problems. You know you're a legit algebra student when you're down with coin problems. Example 83.3. Orlando had a hoard of 22 nickels and dimes. Aha, 22 nickels and dimes. That's our quantity statement. Number of nickels plus number of dimes equals 22. And their value was $1.35. Okay, nickels are worth 5 cents. Dimes are worth 10 cents. And $1.35 is 135 cents. Oh, look, we have it. There's our system of equations. Quantity statement talks about how many of each coin. Value statement talks about what they're worth. We're going to do this eventually with chemicals too. Like you would, like in a chemistry class, you need to do math like this. All right. I said I would flip a coin. Now I need a coin. Looking around to see if I see any. I have a piggy bank right here. You can see it. It's really big. I've had it for years. I think the least I can do is pull there, it's a penny. Abraham Lincoln is going to help us decide. I wonder how much money is in here. It's really heavy. I bet it's at least 2/3 full. All right, ready? Heads substitution, tails elimination. Heads substitution. Okay. So we want one of these to be by itself, right? Let's subtract number of nickels this time. So it'll be number of dimes equals 22 minus the number of nickels, right? That's just rearranged from there. All right, now we'll plug in 5 times the number of nickels plus 10, and then instead of number of dimes, we'll put in that. Equals 135. Yay! All right, we're substituted. Now we distribute. Well, multiplying by 10, I like that. 5 times the number of nickels plus 220 minus 10 times the number of nickels equals 135. Okay, let's subtract the 220, which makes me a little nervous because I see, that's going to be a negative number. But when we combine like terms, that's going to be a negative number too. So I feel better now. Minus 5 times the number of nickels equals, let's see. I need to find the difference between these two numbers, and it'll be negative. But I can't subtract like that. So I'm going to flip the order. 220 minus 135. Now I can actually find the difference. 5, it's 85. Does that make sense? I'll give you a second to catch up. I'm going fast all of a sudden because I'm excited. I want to see what the answer is. All right. Subtract by the -5. There's the two minuses. Yay. I feel good about that. How many times does 5 go into 85? Here's what my brain does. 5 times 10 equals 50. That gives me 35 more. That adds up to 85. And that's 5 times 7. So 5 times 17 equals 85. This is what happens in my brain as I look at this. So I get that the number of nickels equals 17. And then it has to add up to 22, right? I can think of it that way, or I can think of it this way. The number of dimes equals 22 minus 17. Either way, number of dimes must be 5. And guess what? That's the right answer. Good thing, right? Okay. As you notice, the equations can take slightly different shapes, right? In this one, we had one where the number of quarters was greater than the number of dimes. But for the most part, you've handled all the math of this before. The only hard part is looking at the words and pulling out the equations. And we always know there's a quantity statement that talks about the number of coins, and there's a value statement that talks about how much they're worth. And we have to use a little common sense here. We have to remember how much coins are worth. Duh. And we have to remember that 135 cents is the same as $1.35. And we have to make sure that all of this is written in the same unit. And I choose cents. Cents for the win. Guess what? That's the end of lesson 83. I can't possibly drag this out another minute longer. Goodbye.